All right, so now that we've looked at the unit circle, let's come up with a few more definitions. So we talked about terminal points. Okay, so for a given terminal point xy, for an angle t on the unit circle, we're going to come up with some definitions. So we're going to call the x value from that terminal point cosine of t, the y value sine of t, the tangent of t is the y value divided by the x value, the secant of t is 1 over the x value, so you could also write this one as 1 over the cosine. The cosecant is 1 over the y, so I could write that as 1 over sine. And then the cotangent is the reciprocal of tangent. It's x over y, so you could write this a couple ways, cosine over sine, or this is the reciprocal of tangent. Okay, so that's another idea. Okay, so these are definitions, so names given to these values. So here we go. For t equals 5 pi over 3, find the values of all the trig functions we defined here. So I'd probably do a really rough sketch. Let's see, so counting in thirds, 1/3, 2/3, 3/3, 4/3, 5/3. Okay, so at this point, let's see, the x is the smaller, the y is bigger in magnitude but negative. There's my terminal point. So remember, this is the terminal point associated with t equals 5 pi over 3. That's the angle. Okay, so now I have to write out the trig functions. In other words, I need to write the cosine, the sine, the tangent, the secant, the cosecant, and let's see if there will be room here for the cotangent. You can always move that if need be. Okay, so cosine. The definition of that is the x value from the terminal point. That's just a half. That's it. The sine is the y value from the terminal point. The tangent is the y over the x. So the sine over the cosine. Okay, so to simplify that, I could multiply by 2 over 2. So what is that? Negative root 3. Clean this up a little bit. Okay, the secant. So what was the secant? The secant is 1 over the x. So 1 over the cosine. Well, that's an easy one. 1 over a half is 2. So the other way I could think about that one is I could say, well, I know the cosine is a half, so the secant is the reciprocal, so I just flip that fraction. So then I wouldn't even have to set this up. I could just flip that 1/2 over and get 2. So like when I'm looking at cosecant, cosecant's 1 over y, so 1 over sine, or in other words, the reciprocal of sine. So I could just flip that fraction. Okay, now something like that, I have to rationalize the denominator. So I'm gonna move that, and that way we'll have more room for this one. Okay, so let me finish this. Okay, there are my values of all. Let's see, 1, 2, 3, 4, 5. Oh, we still need to do cotangent. Okay, so cotangent, I have a couple ideas. I could set up cosine over sine. That's one thought. Or I could say, well, if I've already found tangent, cotangent is the reciprocal. So that's going to be a little bit faster. So I'm going to have 1 over root 3. Going to rationalize. And now I have all 6 trig functions for t equals 5 pi thirds. So that wasn't too bad. Let's try another one. T equals 11 pi. First, I need to locate that terminal point. So let's see. That's 10 pi plus 1 pi. So 5 pi, well, here's what I'm getting at. So 10 pi plus pi. Well, this 10 pi, this is 5 times around the circle. So that does not affect my terminal point, right? So I know 11 pi is coterminal with pi. In fact, if you've noticed, all the odd multiples of pi land over here. So the terminal point is -1, 0. Okay, so now I can start filling in. This is going to be an easy one. So cosine of 11 pi is the x value. Sine of 11 pi is the y value. Tangent is the y over the x. Secant is 1 over cosine. Cosecant is 1 over sine. So actually there's one that's undefined. I would say DNE, does not exist, or I could say undefined. And then what about cotangent? So that's 1 over tangent, so 1 over 0. So there's another one, does not exist or undefined. Okay, so say I know a piece of information. Say I know sine of t is 4/5. T is in quadrant 2. Find the values of the other trig functions. Okay, I'm just terrible at drawing circles on here, but let's see. The y is 4/5 in 2 quadrants, 1 and 2. It says quadrant 2. So the point I'm interested in, it's somewhere over here. Okay, my goal will be, so I don't actually know the t value, but my goal will be, can I fill in cosine, tangent, secant, cosecant, and cotangent, just because I know sine. Okay, well, one of these I could fill in immediately. Let's see, cosecant is the reciprocal of sine, right? So wouldn't this one have to be 5/4? But how about the other? So here's the thing. I know this is a point on the unit circle. So I know it satisfies the equation of the unit circle, x squared plus y squared equals 1. So now that we've defined sine and cosine, I guess couldn't we write this equation this way? Right, because the x is defined as the cosine, the y is defined as the sine. So typically, here's the way we write when we have a trig function raised to an exponent. The custom is to put the exponent there next to the trig function. So this, I would consider this like the fundamental identity of trig, but this is really just the equation of the unit circle. This is like our very first identity statement that's always true no matter what the value of t is. So, I mean, I can use that equation to move this again. Or I can really just use, I mean, that's just x squared plus y squared equals 1. Like, isn't this what we did at the very beginning of the last section? Like, if I know the sine is 4/5, wouldn't I just write this out like so? And then solve for cosine? We've done this already. Right, 1 is 25/25. Okay, so then I look at my quadrant to determine if x is positive or negative. Remember, that's determined by the quadrant. Okay, so here in quadrant 2, the x is negative. So it's negative 3/5. Okay, now that I have those, I can fill in everything else. So the tangent is the sine over the cosine. Negative 4/3. The cotangent's the reciprocal of tangent. I could fill that one in, huh? And then the secant is the reciprocal of cosine. So if I flip that over, that's negative 5/3. Not too difficult. This is the last one. It's a short section. All right, so here's a similar problem. Tangent is -1/2. T is in quadrant 4. Find the values of the other trig functions. So be careful. Okay, because the first inclination might be this. You're like, okay, Well, I know tangent is the y over the x. So if that's -1/2, let's see, quadrant 4, x is positive, y is negative, so must be the cosine is 2 and the sine is -1. Well, that gives me the correct tangent. The signs look correct. So what is wrong? So the problem is this. This is impossible. Okay, because remember what cosine and sine represent. These are the x and y coordinates of terminal points on the unit circle. It would be impossible for cosine or sine to be bigger than 1, right, in magnitude, because that represents the value of x or y for a point on the unit circle. It has to be less than or equal to 1. So I know immediately this is not true. Okay, so don't make that mistake. So what can I do instead? So it is true that y divided by x is -1/2, but that does not mean that either x, that one of the values is 1 and 1 is 2. It just means that one is twice the other. Okay, so look. What if I say cross multiply here? Let's see, I'd have 2y is -x, so x is -2y. That's what I know, and then I know something else. I know this point lies on the unit circle. So what I actually have is I have another nonlinear system of equations. So I'm going to solve this by doing a substitution. Divide. Take the square root. Rationalize. Okay, so then again, I notice here I'm in quadrant 4, so the y is going to be negative. So now I know the value of sine. Okay, so the value of sine is going to be the negative √5 over 5. Okay. How do I get the cosine? Well, actually, I would use this equation. Look, I know x is equal to -2y. Get rid of that. So if I know x equals -2y, then all I have to do is put my y in here. Okay, and then I have my cosine. 2√5 over 5. And then the rest of these are just going to be ratios. I might want more room. Let's see if that's good enough. So the tangent is the sine over the cosine multiply by 5 over 5. Oh, that's cool. Look, this cancels, this cancels. I think I already knew this, didn't I? Wasn't this the problem statement? Look at that. So I actually already knew that information. But I've just checked my work then, huh? Okay, secant is the reciprocal of cosine. So I flip this. So 5 over 2 root 5. So 5 root 5 over 2 times 5. These cancel. Okay, cosecant, the reciprocal of sine. That'll be negative 5 over root 5. Rationalize. And then cotangent, that's the easy one. Reciprocal of tangent, so that's just going to be negative 2. And then we have